Today we're going to look at solving exponential equations using a hand method as opposed to technology. We'll do some technology tomorrow, but today we'll do some by hand methods so we know how this works. Remember, an exponential equation is any equation that has an unknown exponent as the variable. And there really are only two sort of rules you need to worry about when you're solving an exponential equation. If you can make both sides have the same base, then that means the exponents have to be the same, which means we can solve it. Okay, so our objective here is to make things into the same base. So, for example, we'll take a look at the first one here. I want to solve this. I have an exponential equation. I have an unknown exponent. 2 to the power of something makes 8. Well, off the top of my head, I can think of 2 times 2 times 2 is 8. In other words, 2 to the power of 3 is 8. Because my bases are the same, these two both are 2's, that means that these two things have to be the same. In other words, x has to equal 3. Now that one kind of makes like common sense, right? 2 to the power of 3 is 8. But this idea of if I make my bases the same, my exponents have to be the same, can apply to things that are more complicated. Okay, let's try the next one. 9 to the power of x makes 729. 9 to the x. Well, if I can make 9 to the power of something be 729, I can try guess and check here. I can try 9 to the 2. Oh, yeah, it's 81. No, it didn't work. 9 to the 3. What's that going to be? 83 times. Hey, it's 729. Oh, well, 9 to the x. Oh, sorry, not there. 9 to the x equals 9. Well, 729 can be written this way, right? These two things are basically equivalent, so I can replace 9 to the 3 with 729. In other words, x has to equal 3. My bases are the same. My exponents are the same. And try the next one. 14 to the x. Okay. I want to make these things the same basis, which means I need a 14 to the power of something. And I got to think to myself, well, 14 to the 1, that would be 14. 14 to the 2, 190. Oh, this is getting worse, right? I want to get to 1. Can we think of anything 14 to the power of anything that makes 1? If you remember one of our trick questions, one of our exponent rules, anything to the power of 0 always comes out to 1. And again, because my bases are the same, my exponents have to be the same. In other words, x has to be 0. And our key here is if I can make both sides have the same base, then I can solve their exponents. And we'll try a couple other ones. Hey, I got a fraction one this time. 3/5 to the x. Okay, so I got my 3/5 to the x. I want to make this side 3/5. I want to make the bases the same. So I got to think to myself, what exponent would make 3/5 into a 9/25? Well, 3 to the power of 2 is 9, and 5 to the power of 2 is 9. So does it not make sense to have 3/5 to the 2? And since my bases are the same now, my exponents are, oops, that's a 2. My exponents are the same now. Okay, let's try e. My base is 5. 5 to the x. I need to make this into a 5. So I start thinking, 5 to the 1. Well, that's 5. 5 to the 2, that's 25. 5 to the 3, that's 120. Hey, that's kind of what I have here, right? But it's a fraction. Now, what do we know about fractions? Fractions happen with negative exponents. So if I want to make this into a 1 over 125, well, 3 makes sense because it's 125. If I make it a negative 3, that'll flip my base, create a 1 over 125. Well, since my bases are the same now, these are both 5's, that means that my exponents have to be equal. If it's still confusing a little bit, think of this. What is 5 to the negative 3? Well, that's 1 over 5 to the 3, which is 1 over 125. That works. That's what we wanted. Okay, let's try the next one. Next one looks a little more complicated. 4 to the 3x minus 1. It's not just the letter x anymore. This is kind of our objective of these kinds of questions. Yeah, I need to make my bases the same. 4 to the 3x minus 1 equals 4 to the what? 4 to the what is 16. Well, 4 to the 1 is 4. 4 to the 2 is, hey, that 4 is 16. So 4 to the 2 is 16. My bases are the same, which means my exponents are the same. So I'm going to write down this time the exponents. 3x minus 1 has to equal 2. And then solve that. Numbers on one side, letters on the other. So 2 plus 1, which is 3, divide both sides by 3, and x equals 1. If I weren't unsure about it, I want to test that theory out, I'd go back to the beginning and put this back in up here, right, and see what happens. 4 to the power of 3 times 1 minus 1. What's that give me? 4 squared minus 1. Sorry, 4 to the 3 minus 1, which is 4 to the 2, which is 16. Yeah, it worked out. Left side and right side are both the same. Yeah, it's just a way of checking things. Okay, let's try some more. Hopefully you can pause at this point and try and work your way ahead a little bit to get it when you're not so sure about. Okay, letter G here. I have my base. 3 to the x plus 2. 3 to the what makes 27. I guess and check a little bit. 3 to the 1, 3 to the 2, 3 to the 3 will work. Bases are the same, so exponents must be the same. Numbers on one side, letters on the other. X must be 1. Okay, try the next one. 7 halves to the 3x. Okay, so I need to put this thing into 7 halves to the power of something. Just taking a look at that. 7 to the power of something is not going to be 4, but I know that 7 to the power of 2 is 49. So what's happened between the fraction base I want and the fraction base I have? It kind of looks like they've been flipped upside down, right? How do we flip things over? We use negative exponents. So now if I'm thinking about it, 2 to the power of what? Upside down would be 4. That would be a 2, right? And same thing, 7 upside down goes to the bottom. To the power of 2 would be 49. That seems to work. So if my bases are the same, my exponents must be the same. And if I want to solve this, x would be negative 2/3. Okay. Okay, letter I. Oh, letter I is kind of nice. Look, both sides are same base. What do we know right off the bat then? Our exponents have to be equal. I can solve this. Numbers on one side, letters on the other. Hey, I didn't need to worry about making the same bases because my bases were the same. If I rearrange cross my equal sign, opposite operations, I've got 4 on one side and x on the other. And again, if I wanted to check it out, I could. 2 to the 4 plus 3 on the left side. 2 times 4 minus 1. What happens here? On the left side, I got 7. On the right side, I got 2 times 4 is 8. 8 minus 1 is 7. Hey, those two things have to be equal, right? We've just proven it. That happened when x was 4. Let's try a couple more. Okay, 3 to the x plus 3 and 9 to the 2x minus 6. My bases are the same. Okay, so I need to make this into a 3. 3 to the power what is 9? Well, 3 squared, 3 to the power 2 is 9. Now here's where we have to be a little careful. This is my 9. The 2x minus 6 is on the outside of that, right? Like, remember, we're thinking about this whole thing right here. That's replacing 9. So what already happened is I've got a power of a power now. So on the left side, my exponent is x plus 3. On the right side, to figure out the actual exponent, I need to take the 2 on the inside of the bracket and multiply it with the 2x minus 6 on the outside of the bracket. Because our exponent rule, when we have this situation, is we're not supposed to multiply at the power of a power. That's rule number 3 we did in the first day of exponents. Okay, so to solve this, I need to expand my brackets. 2 times 2x is 4x. 2 times negative 6 is minus 12. Numbers on one side, letters on the other. So I'll have 3 plus 12 equals 4x minus x. 3 plus 12 is 15. 3x on this side. Divide them both by 3's. And I got x is 5. Okay. So sometimes we have more than just an exponent. We're going to have a power to a power. That can happen. Okay, let's try k. 4 to the x. I want to make this into 4 to the power of something. If I start working with this now, 4 to the 1 is 4. 4 to the 2 is 16. I got a problem, right? 8 is somewhere in between those two things. That's going to be some sort of decimal exponent. I can't think of decimal exponents that come out to 8. So I've got a little problem here. If I can't think of a base to an exponent that I need, maybe that's not the problem. Maybe the problem is that I need to change both of my bases. Is there a common base that I can turn both 4 and 8 into? Well, there is. Okay. If I turn this into a 2 on this side and a 2 on this side, those will be the same bases. 2 to the power of what makes 4? Well, 2 squared makes 4, right? And it has an x on the outside. So move this equal sign over here. Sorry, guys. Okay, and on the right side, 2 to the power what makes 8? Well, 2 to the 3 makes 8. And I got the x plus 1 on the outside. So because I couldn't make a 4 into an 8, I had to go smaller. I had to make a smaller base and choose a value that can make both of the things into. And that's going to happen from time to time. Now we said a second ago, when you have a power is supposed to multiply. So I'm going to write this out as multiplying. So 2 times x. You can just write 2x if you want to. And 3 times x plus 1. So if I expand my brackets, and be careful, make sure you multiply by both things, right? And then I rearrange this. Numbers on one side, letters on the other. I'll get negative 3 on this side, and I'll get x is negative 3. Okay, so the trick on that one was both bases need to change. Try and make it one base first, but if that's not possible, then change both. Okay, let's take a look at L. Can I make 25 into a 125? Well, let's try it. 25 to the 1, that'd be 25. 25 squared, that makes 625. Somewhere in between, which means I need to change both of my bases. What can I make these both into? What's a common base? Well, I think a nice one might be the number 5, because 5 squared makes 25. And on the right-hand side here, 5 to the power of 3 makes 125. Okay, so I made them both into the same kinds of bases. I got powers of powers, so I need to multiply. I'm going to write that out as multiplying. Okay. And then I'm going to expand my brackets. 2x plus 4, 3x minus 3. I'm going to rearrange it so numbers on one side, letters on the other. When I cross the equal sign, make sure to do the opposite. 4 plus 3 is 7. 3x minus 2x is x. Okay, I've solved it. X is 7. And again, it's a situation where I had 2 bases that need to be made into the same thing because I couldn't make a 25 into a 125. And that's how we solve exponential equations. Okay, try the homework, try the quiz, and move on to the last lesson in this unit. Okay, there's only 5 unit lessons in this one.